Hi, everyone. Thank you for joining today. We're going to wait just a few moments for everyone to jump on before we start our live session.
And while we are waiting for the people who already joined, at the very end of the last slide, I will put my link to Twitter. I should have put it in the beginning, but I would like to hear your feedback about the presentation, whether it was useful or not. Some possible ideas for future webinars. If you think like, I would like you to have a webinar on this topic more specific to one of the things that we're going to discuss today, that will give us more ideas for future webinars. And if you want to discuss about the other topics that we are going to see today, like music, also feel free to reach me on Twitter, and then we can talk about that as well. Yeah.
Awesome. It looks like we have a good number of people logged in now. So hello, everyone. Thank you for joining us today. My name is Courtney Brown. I'm a senior marketing manager here at EDB. I'm going to be your host today for our webinar, Variations of PostgreSQL Replication. I'm joined by Boris today, Holistic System Software Engineer at EDB. And just briefly before I turn it over, I'm going to go through a few housekeeping items. This presentation is being recorded. We'll be sharing the recording along with the slides after the broadcast. The lines are currently muted. If you have any questions, please feel free to submit it in the question panel. Today's session is scheduled for about an hour. We don't expect the presentation to take the entire time, so we'll allot any extra time for Q&A. If we don't have a chance to answer your question today, though, we'll be sure to follow up afterwards with any attendee whose question was not answered. So without further ado, I'll hand it over.
Thanks a lot, Kearney. So I'm a holistic system software engineer. That means that I try to look at the entire picture. That's not the official title, unfortunately. So my official title is actually solution architect at EDB. But I'm also an air guitar player, something that I enjoy daily. And I have a lot of fun with music and with Postgres. So we're going to talk about variations on PostgreSQL replication. And why this talk actually is because sharing knowledge, I think, is the basic for having a very good open source community. Open source is what drives us. And if we share the knowledge, we are all going to grow together. So whatever you can learn here, I'm also glad that I can learn from you discussing after the presentation. And I'd like to get all your feedback. The other reason for doing this is because for me, it allows me to mix two things that I like a lot, music and replication in PostgreSQL. So at least I am going to have fun. I hope that you are going to have fun too. And if you already watched this presentation in Postgres build, that was a short version. This is an extended version, so you can still kind of review some of the concepts and learn a little bit more. And I'm also going to go to the console and I'm going to do some hand-on things so that you can see some of the concepts. This is not a tutorial about how to set replication, stuff like that. If you want that, please let us know. But I'm going to just touch some of the concepts that I think that are really important in order to understand the whole thing. So if I go to the technical part, is to understand the high level concept. So this is a mix between architecture and then technical considerations that you need to have. And the last reason is because I like to make drawings, and this kind of presentation allows me to draw a lot. So if you don't like the drawings, it's fine. I mean, I'm not a professional drawer, so just like it. Good. So talking about combining things, I mean, I'm not the only one. Kiko Loureiro, which is a great guitar player. He has an open source album called Open Source. He released last year, and well, you can download it and you can make your own music based on this album because he released all the tracks. Like we release code, he releases the tracks as well. So you can make your own versions of it. So check it out. I think it's a very good listen, and maybe make your own stuff with his music. It's open source. So what we're going to try to achieve today, it is to evaluate different kinds of replication strategies, going from asynchronous streaming replication, and then going to synchronous, and then going cascading replication and logical replication as well. So we're going to see all of them, and I hope that you're going to get the most of it. And when you get to the end, you will see that this kind of diagram is going to be quite easy to understand. And now it kind of looks like bloated with information, but when we build it little by little, you will see what I mean by this diagram here. So I said building it little by little, that means going back to the roots. And the roots of heavy metal, if you search a little bit in history and the style of music, is definitely in blues and rock music. And the same way, streaming replication has its roots in backup and recovery. So this is very important to understand. Backup and recovery is really the essence of doing replication. And look a little bit at the letters there, uh, B and R. Is it a coincidence? It is. It's just a coincidence. No real relationship there. So let's look at the backup and recovery then. You have here PostgreSQL, you have the memory there on top, your shared buffers, your wall buffers, and you have your data directory and every change that happens in the shared buffers. When you read something and then you modify it, is going to go to the wall directory. So this is going to keep all the changes in case that if the RAM it is gone, you can recover change from the changes in the wall files. This idea allows you to take a backup, a physical backup, which is a copy of your data directory plus all those changes. This one actually allows you to do point-in-time recovery. So you put this somewhere and then you can redo all the changes and you get exactly the same database. So the idea is that when you do the recovery, you launch it again, and then you replay all the walls on those shared buffers, and you have a new instance of that. Then the guys of PostgreSQL, the elders of PostgreSQL, they had the great idea of not just doing backup recovery, but taking every change and stream it to a recovery instance that is constantly replaying all the changes. So what it's going to do, it is going to be a recovery forever, unless you promote the node. So after writing the changes on the wall directory, what is going to happen is that when you set up replication, it is going to have a wall sender, which is reading every change from the wall and is going to send it to the wall receiver, which catches, writes it down to the wall directory, and from the wall directory, it can be replayed on the shared buffers. This last step is not compulsory. It's enough that you have it on your wall, but replaying it allow you to have a read replica. This is what we call a hot standby. Right? So you can read that information on the shared buffers over there. So you can have your queries over there. So this gives you already some extra things that we are adding. So this is constantly being and recovering. So I'm going to use the term master and replica. I know that this is kind of controversial. I like to see master as when you have music, you have your master copy when you do your recording, and then from that master you create all the copies of your music. So in this case, I think it fits well, especially when we go to logical replication. You're going to see why. So just take as a synonym primary master, and they go to replica or standby. Okay. So this is the reason why when you go to a master node, you ask whether it's in recovery or not, it's going to tell you false because it's not in recovery. If you go to the replica and you ask the same question, then it is a yes. So let's do that. So I told you that we were going to go to the console, and this is a kind of the more like the heavy down part. So let me check here a query. Select is in recovery. This is a master node. The database is called vacant for some reason that you will see. You probably know already. And tell me this is false. Okay, that's good. Let me go to this other node, which is the replica, and it tells me true. So as you can see, there is no query that say like, is this master or is it primary or is this replica? No, it's really down to backup and recovery concepts that I told you. It's like when you're listening to music, which is metal that evolves from blues and rock, you can play the blues scale and it's still called blues scale. It doesn't change to metal scale because you're playing in the metal concept. So that's the roots that you are there. So that's why it is called like this. So how do you know whether the replicas are listening to you? So when you attend to a music concert, sometimes you have the singer shouting at the people like, "Can you hear me?" That's the feedback that you get. So Postgres will do exactly the same. You get statistics of the replication. So you can query this table, select everything from PG underscore stat replication, and then you're going to see whether the nodes are listening or not. So you have plenty of information here. You have the LSN, which is the log sequence number that you're sending, and whether it's being received and it's being put down or not. So let me show you that again. So I go here and I do select everything from PG stat. If you forget, you can always do tab replication. It's tab completion. It works really well. Oh, this is not so nice. Let me get back to this display. And you can see here exactly the same information that I'm showing you in the slides. you have sent this information and it's being acknowledged by the replicas. I have multiple replicas here. That's why I have multiple lines on this query. And here you can see also the lag. So you can measure the lag either in time or in bytes. In this case, there is no lag in bytes because what is being received and written, it is exactly the same that is being sent. Now, why do we have three things here? We're going to see this in a minute. Note extra, this is asynchronous replication. So you can see the async on the top, on the bottom, sorry, of this slide. Now, this is the drawing of sending the stream of changes from the primary node to the standby node, the physical stream of replication. And before we go to the tree of heavy metal, when things are being received by the wall receiver and being sent to the wall, this is the write LSN. When it's being flushed to disk, this is really physically on the disk, not just waiting on the kernel to be flushed. That's the flush LSN. And when you get here to the share buffer, is being replay on the other node. So these are the three things here: write LSN, flush LSN, replay LSN. Good. So let's go now to the tree of heavy metal. The tree of heavy metal, we saw that the roots are in blues and rock. And heavy metal like Iron Maiden, this kind of classic stuff, Judas Priest, evolves into some different styles. So there are variations of heavy metal. So one of the variations is power metal, actually. Power metal is kind of faster and has a happy lyrics and sees the world in a different way. So if you talk to somebody which is a fan of power metal, you will see that their mindset are in a future world and they all live in happiness and their heart is full of joy and they say the word tomorrow without fear. That's the power metal. So that's why we have power to Postgres as well. We want to have a future of Postgres without fear. So from power metal and all these stories of dragons and all this stuff, you are a violin and you slow down a little bit the beat because power metal is really punchy, and you get folk metal. So it's a variation. You change one thing and you get folk metal. Now, if you add many violins, you get symphonic metal. Yeah, there you go. So a variation is just by changing some little things that. Well, let's go to Postgres, back to Postgres. We have physical streaming replication. We have its roots on backup and recovery. Yeah. If we add something extra, like putting a standby node behind another standby node, we get what is called cascading replication, which is very useful when you have multiple data centers. We're going to see that in a minute. If you change the way of deciding when something is being committed, you wait until it's being synchronous at the other side and you get a feedback say like, yes, I got the value. Then you have synchronous replication. It's just one little change and then you get a different approach for replication. And then something that it goes a little bit more like opening different doors. So that's why I put it at the center of that new branching of a variation is logical streaming replication. Still streaming, but it's done in a logical way. We're going to see that also. So this is what we're going to get. Let's see a little bit more about asynchronous replication. You have a node here, which is a primary node. The arrow that I'm going to use here with a little black head, it is the asynchronous replication. Yep. So you have the primary node and the standby. What you can do is you can add multiple replicas. You saw that when I was doing my query, I had multiple rows on the statistic of the replication. That's because I have multiple replicas. And then what you can do is, because you can read in all this replica, you can do horizontal scalability for reads, not for writes, because you can write only on the primary node, but for reads. And so you can have a PG balancer, yeah, or another pooling, and you have two channels. It's important that the application knows what are the queries that writes information, what are the queries that read information. So everything that is read-write goes to the primary node, and everything that is read-only can scale and go to the replicas. This is asynchronous reading and the replication. So there you go, read scale, horizontal read scale. This is how this is called. Very useful when you want to, when your production's primary node is exhausted with resources and you want to put all the reads on other nodes, it helps a lot. Yeah. So robustness, this is the other reason of having replication. Yeah. So if one of the nodes fails, your system entirely is robust, and then you continue functioning. Yeah. You have in one data center your primary node and your standby node, and then you have another location, another data center, and then you also have a stream of replication from the primary node to the second node. Then you add cascading replication. This is when it becomes useful, because the third node, it doesn't replicate from the primary, but it replicates from a replica. And that's why it's called cascading replication. Okay. And the idea is that here, if one data center goes down, the other one already have this structure of primary and replica. So recovering was going to be much faster. And then you know that you are good in your recovery time. Now, the other reason why this is important, if you look at some services that charge you for the amount of data that you transfer from one data center to the other data center, here you are reducing by half your cost of data transfer between the primary data center and the disaster recovery data center. Good. Let's see some example here. Let's call the primary Wacken or Wacken, proper pronunciation. Forgive me, the people from Germany. And you have that replicates to rock in the same data center, and then to metal on the other data center, and to power, which is the cascading replication, because power metal evolves from heavy metal. Okay, so it is really a fine line between cascading replication and normal replication. So the only thing that you have to do to change this, it is in your primary connection info, say which one is your host that you are connecting to. So let's get back to the names. So if you see metal here is going to replicate from vacuum, and power is going to replicate from metal. That's the only thing here you have to do. So your primary connection info is going to be, well, you have the same user, for instance, and then you have the host, which is going to be different. And then you have here, well, the port and the application name. The application name is very important because it's going to identify who are you connecting to the master, because the master needs to identify multiple nodes. And if you don't put the application name, which is optional, the master, well, the people doing the administration with the master doesn't know who is who. In this case, I identify the nodes. So let me show you that on the console just very briefly. So this is the node, which is so show primary connection info. This is the metal node. See, it connects to Wacken, and this one here, no, I have it here. This one, it is replicating from metal, and show primary connection info. It says that connects to, oh, this one connects to Wacken as well. Which one is this one? Let me see. I changed this at the last minute, sorry. Well, this one should go to metal instead of going to that one. Okay. Well, you see, this is different here. Okay, so that's cascading replication. There you go. Now, when you want to have automatic failover, the problem with network connection is that when you don't see the information coming from a node, you don't know whether this node is actually dead or is only the connection that is being dead. So you need to have at least 3 participants in order to decide whether you can do automatic failover or not. So that's why you have a witness. It doesn't have to be a Postgres node, but you have there the eye of the beholder, which is going to talk to all the nodes in order to be able to perform an automatic failover, because it's going to decide, okay, we really need to have a switch or not. So let's say that there is a network problem between the data center on the left to the one on the right. The one on the right don't know, so they are going to get information from the witness saying like, don't promote because the primary is still alive, I can talk to it. Yep. You have a lot of this kind of situations in network. Network is not transitive. So if node A can talk to B and B can talk to C, it doesn't mean that node A can talk to C. So this is very important to consider. One expects that to be normal, but it's not. So you don't have transitivity. And the same thing, it could happen that instead of having the entire data center that is down, that nobody can see the data center there, and the node is going to be isolated. The good thing here is that because you have at least 3 nodes, you have a majority, so the witness can decide with the other side to promote automatically, and the one that is isolated, it doesn't see the witness, it says like, okay, I'm in the minority, so I probably should better shut down to prevent split brains. Okay, so it's very important to have the 3 sources in order to have automatic failover. Very important. Good, so cascading replication. What you can also do, it is protect against human error. And this is delaying one of the nodes that are, I don't remember why they want. So delaying one of the nodes that is replaying the information. So it's receiving all the walls, but it's not going to replay them immediately. It's just going to hold them for a certain amount of time. You can say like replay it only after 3 hours. So it's like you get an envelope and the envelope said, do not open this until 3 hours from now. And then you can replay the stuff. So it's always going to be kind of in the past. So if somebody by accident deletes a table, instead of doing a full point in time recovery and triggering alarms and everything, you just contact the replica that is delayed, and then you say like, stop replaying. We need to recover the information, and then you are back on with all the data. So this is called delayed replica. One way of doing that, and now remember why I have this switch here, is because I did have automatic failover, and I killed this node doing some tests, and that's why I connected to the other one. Apologies for that. So let me do this the following then. I have here a table called orders, table orders. Yeah, nope, that's not so nice. Let me get back to this, table orders. There you go. And this one I also have the table orders because it's a replica. There you go. It's exactly the same table. And what I'm going to do, it is I'm going to say select PG wall replay pause. So everything that is being received is not going to be replayed. So now if I insert a value here, insert into orders, and then I'm going to order about number 5, customer 1, and then what is going to order again, water, it's very thirsty people, and then number 4. What did I do? I missed values. There you go. So I do table orders. You can see that I have the value here, but if I do table orders here, it is not. So even if I drop all the information, I could still see the values here. So that's what happens when you have a delayed stuff. And what I'm going to do now, it is look at, again, select, nope, like that. And then it was here from start replication. You can see this is the node metal. And you can see that what I have been sending is this one, what is being written and flashed to disk. Yeah. It is ahead of what is being replayed. So the replay here, it is actually a delay. I haven't replayed everything. So as soon as I do here, instead of doing pause, I do resume. I can see that my value arrived here. So I have my data here. And I query exactly the same thing here. I can see that now everything is in sync. Fine, replay actually catch up. That's how you do it. So what happens here is that you send information, and then just before you replay it, you make it a pause. You can do this automatically, or you can do it specifically, especially if you have to take a backup, like, well, no, it's not really a backup, a snapshot with PG dump. You get information, you pause the replication, you get information, and then you resume, so you avoid having problem with conflict with snapshots and everything. So another pattern that protects you from human error, because we human, we make mistakes. And we should celebrate that, because every time we made a mistake, we learn, like I did with the automatic replication in the previous example. So reduce data loss. I don't know whether this is written like this with double S, but at least it looks nice. English is not my native language, sorry. By the way, somebody's asking whether I issue commit or not when I did the insert. I'm using PSQL, and what is happening is that everything that I run there is a transaction. Yeah, unless I do begin, then I open a transaction which has going to have multiple queries, and then until I say commit. But if I don't say anything, no begin, everything is one transaction, so it's auto commit all the time. So every query that I do insert is actually committing. So good question, because if I do begin, insert, and I don't do commit, the values are still not visible at the replica. Thanks for the question. So synchronous replication. This means that when I commit, yeah, I'm going to receive like a commit. Okay, fine. When does it happen? Yeah, so this is the question, commit. You saw this table here. Now we have here, which is synchronous at the end. Yep. And it's going to be synchronous based on this value, the synchronous standby names. Okay. So this is going to tell me who is replicating. By the way, who is replicating is not a statement like the node who is replicating. It's a question. So question, who is replicating? And I know that with the synchronous standby names here. And then I know, okay, this one is synchronous node. What is going to happen here is that I have a decision of 3 different places where I can say, I consider this to be synchronous, either when it's being received, when it's being flashed, or when it's being replayed. And I can decide with the value of synchronous commit there. Okay, so there you have again this diagram. You can see here that when it's being on the synchronous commit, it has to be on the wall directory being flash. Okay, if I have remote write, it is the moment right before the flash. So when I just write to disk, yeah. So when you copy things to the USB stick, but you haven't unmounted yet, the unmount is the flash, right? So you write it. The flash is when it is physically on disk, and then the replay is when it's on the shared buffers. So those are the three positions. Now there's a fourth one, which is called local. Yeah, I added here. That means that all my queries are going to be locally synchronous. Yeah, so they have to be on the wall directory. But then dynamically, I can decide to make them synchronous at the replica as well. So that's important. That means synchronous locally, and I will decide when it's going to be using the synchronous standby names. Okay, so that's the thing. So you have an hybrid way of information. By the way, we're going to have some polls, and there are 2 polls that we are going to answer. Karen is going to prepare them. You're going to have some minutes in order to tell us whether you're using replication or not. And then after a few minutes, while I'm presenting the synchronous commit, you can tell us whether you're using synchronous commit or not. So check out the polls on the webinar infrastructure, and then you can answer and give us some feedback.
Sure, I'm going to launch the first one right now for you.
Right, thank you, Kearney. So here you have standby names. So I'm extending this. The replicas at the side of the primary node have also blues and rock, and then have metal and power at the other side, cascading replication. Then those are the standby names. Okay, so that's important. You can take different decisions about how you're going to replicate. You can say like the first one of this list of standby names have to reply. So when I know that metal got it, then I consider this to be a synchronous commit. In this case, it's not a good idea because metal is at the other data center, so you have larger latency, so you have to wait longer. So it's better to have either rock or blues in this case. So that's the second one. And instead of saying like the first one, I want to have at least 2 nodes that tells me. So I want to have at least 2 standbys having the same data as the primary, so that if I crash, I have this guarantee that the data is there. And if one of the 2 fails, I'm happy to wait a little bit more so that metal can also reply. So that's why the list of the order is very important. Now, if you don't care about the order, you just put any 2 of these nodes, rock, blues, or metal, any of the 2 of those 3 that replies, I'm fine and I can continue. This is very important because if some of them are down and they're not replying to the master, then you're not going to be able to write anything, because you said I really want to have 0 data loss. So if you cannot guarantee 0 data loss, you cannot write. Yeah. So that's very important to consider. It's crucial. So you have the parameter synchronous commit, where you can be remote write on remote apply, remember, or it can also be local. I like the local one because it allows you to dynamically change. It's an hybrid way, so you can decide. So synchronous when it's important. Yeah. Let's look at this example. So you have synchronous standby names, can be anyone, metal, rock, or blues. Yeah. And the synchronous commit is being set to local. Yep. That means, let me show you this here. So let me get back. So this is my primary node. So show synchronous standby names. Yep. So I had first rock. This is before we get to the other example. So let me show you this. So I can insert again some orders. Remember, this is going to be a transaction that is going to commit immediately. So let me say 6. And what I'm going to do, I'm going to stop this node. That's why I was playing, and I broke the cascading replication. So this is node rock, and I stop it. Yeah. I cannot write because I say like I really want to have that rock replies before I say that something is committed. That's why it's important to have at least 2 nodes extra from the primary in order to have synchronous commit. Otherwise, it's a bad idea. Only when I start this node, okay, I started and I finished my transaction. So that wasn't such a good idea to have that. So let's get back to our example. Let me have here my list here, this one here. So this is not going to be that dynamic because I can set, so alter system set synchronous standby names, anyone between metal, rock, and blues. And then I have to say, let me show the synchronous commit is set to on. I want to have that to local. So alter system set synchronous commit equals to local. Yep. And what I have to do now, it is a reload of the configuration. Reload configuration. Yep, true. Okay, good. So now I have the same thing that I was showing to you on the slides here. Yeah. So let me show you the advantage of that. So what I'm going to do is that temporary, I'm going to say set synchronous commit. This one, I don't have to reload anything. This can be done per query. Yeah. This one is going to be remote apply. So I want it to be available at the other node. Yep. Okay, good. Now I'm going to do the same insert of orders. Yep. So number 7. There you go. It's fine. It's working. It's being remote apply. So it's synchronous commit. I'm going to do exactly the same now, but now I'm going to stop again this node, the rock node. I'm going to run it here. And now it commits because the other nodes, metal and blues, those are available. So I can continue writing, no problem. So let me stop the others node then. Let me stop blues. Let me stop. I have to exit here. Look, by the way, I'm doing systemctl with the user Postgres. So you can do that. It is, so you don't need to have administration of the entire system in order to stop or start Postgres. You can say Postgres can do sudo systemctl only for the Postgres service. If I try to do it something else, it's not going to work. So you can really restrict your Postgres user to do only this kind of operation. So I stopped them. So look, sudo ls, say I cannot. So Postgres is really only going to be able to stop or start his service. So I stop the 3 of them and I insert here and I block because none of the 3 is replying. So this is very important for synchronous commit. So Courtney, can you give me a name between metal, rock, and blues? So I start one of these.
Sure, let's go with metal.
Metal. So this is the one. It's the last one here. So let's start it. And the commit finish. So any of the nodes is allowing me to continue, and it doesn't matter. So that's good. So it gives you more robustness there. I like that. So and this is just because I decided to be synchronous. By default, this is going to be asynchronous. Okay. So this is the pattern. So you set synchronous commit to remote apply. Yeah. Let's say that you are in a festival and you are ordering beers, and this is the order number 2,267,709 in a mission of for the rights of all the numbers. This is actually the phone number of Douglas Adams when he was writing the Hitchhiker's Guide to the Galaxy. And the customer, where if you look at the table of the customer, this is actually Lucius Ferdinand, and he is ordering 18 beers, not because he drinks too much or he has too many friends, but well, he has friends and he wants to share them, but because 18 is actually this in a binary representation. So if this is a binary number, this is 0, 1, 0, 0, 1, and that's 18. Yes, it's 2 plus 16, 18. This is 19. 19 is like kind of wannabe metal, so that's not good. So 18 is the best. Yeah, there you go. So you learn something about binary numbers and metals greetings. Good. So, and then I can just do reset synchronous commit. So let's see this. That means that if I go back to here and I say reset synchronous commit, yeah, and I do now show synchronous commit, it says local. That means that all my transactions are now going to be local. So now I can stop again here, metal. So neither metal, blues, or rock is running now. And I try to do the ordering. It works because I'm committing locally only. I don't rely on all these other nodes. So I only do it synchronous when it's important. So think in terms of transactions with money and stuff like that. At a certain amount of money, you want to have 0 data loss. Okay, so that's synchronous replication. Remember, if you have 2 nodes, look at the arrow. The arrow is white. Yeah, so it means that it's synchronous commit. This is actually fragile. Yeah, we don't like that, because if the only node that you have as a standby crashes, you cannot write anymore. So not a good idea. So you need to have at least two. Yeah. So remember, replication and the root, backup and recovery, that you have two. The other possibility is you have more robustness. This is one data center. So if you want to have two data centers, you can have it like this as well. It's even better. And you can even have cascading replication. Then you can play actually with one of them being synchronous and the other one being asynchronous. So you don't need to have synchronicity for everywhere. Now you can also say like everything that goes to the other data center is asynchronous and only locally is synchronous because of the latency and stuff like that. And then you can play actually. So dynamically, this is asynchronous, this is synchronous, asynchronous, synchronous, asynchronous, synchronous. Good. Intermezzo culturale. So probably you're a little bit tired. So before we go to logical replication, I want to tell you something about heavy metal. So I also like to read books. And because of reading books, I actually started to listen to, because I was reading Lord of the Rings, I started to listen to Night Witch and Blind Guardian from Germany, and the other ones from Finland. And not only in that direction, from books to music, but also from music to books. So thanks to Iron Maiden, for instance, I started to listen to read The Rime of the Ancient Mariner by Samuel Coleridge. So I learned about English poetry, and also Lord of the Flies, which is actually a very good book, thanks to heavy metal. So why do I mention this? It's just to kind of reduce stereotypes about headbangers and metalheads. We also like to read books. And so if you have a friend which is a headbanger in his next birthday or something, you can give him a book or her a book, and she's going to be happy, probably. Good. So let's continue. Let's get back to the tree of physical streaming replication, and we go to the logical streaming replication. What do we get here? We have this diagram for physical streaming replication, and we are going to change now. Instead of having the wall sender and the wall receiver, we're going to have here a logical decoding. So the wall sender is going to have an extra piece of information that is going to, instead of saying the block of pages that have to change, I'm going to explain what is going to be the change that is going to happen on a certain row. So say this row now have this value if you do an update, or this table now have a new row and these are the information. That means that you can send this information to another PostgreSQL that has a different version, for instance, different major version. Physical replication has to be done only with the same major version. Logical replication allows you to mix this kind of thing. So it allows you to do like upgrades online, almost zero downtime. So instead of having a wall receiver, at the other side, you have a downstreamer. So you have the upstream and the downstreamer. So one is the publisher and the other one subscribes and gets information and set it down. So a logical downstreamer, for me sounds like a character in one of the songs of Ronnie James Dio. Like you have the stargazer, the downstreamer, the holy diver. Sounds like that. So I like the downstreamer for logical. So the logical downstream is not going to write directly to the wall. It's going to first put the things available on the shared buffers logically. So you can see that the block here, it's not exactly the same as the block here. So the change might be applied in a different way. And then it's going to go through the wall buffers to wall. So it can be sent to another node and streaming replication from this wall here to another stream replication. So you can combine this logical and stream replication. But it's important here is that you're not sending the query, actually. You're not sending insert, you're sending, this is the new row, actually, the new value of the row. You can do deletes as well, yeah? So it's a logical decoding of what is going on. So this node here is actually a primary node or a master, yeah? So you can write to it. And because you can see here, the other side, yeah, this node can also write things. So they're both master. So that's why I like to use master in this sense, because primary, I mean, if you have multiple primaries, nobody's primary. So for me, it sounds better to have master. This is the multi-master architecture, actually, based on logical replication. It's not bidirectional replication. You can publish different sets of tables and then exchange them, but the same data sets you cannot exchange between the two. That's bidirectional replication or bidirectional replication if you're from Australia, I guess. And there are things like a BDR, which is a product of EDB. which we're not going to discuss in this presentation, but then it's an extra level, which is goes, you have the tree logical replication, and then on top of that, you can have BDR, which is based on logical replication. But this is how you build up a master-master replication and with the available tools that you have in open source. Okay, so we're going to see a little bit of that. As I told you, it allows you to do an upgrade of to a major version. Yeah. And looking at the time, we have time for a demo of the logical replication. So I want to show you a little bit of that. So let me get back to this here. Remember this logical decoding, sending to the downstreamer, and then it applies to the table here. So what I have here is, now those are the physical replicas. This is my other master. It's called Oulu. It's from the north. This is a place in Finland where you have the International Championship of air guitar playing. Yeah, and I do have here a table called air guitar players. It has an ID, a name, and a year where they were champions. Okay, so what I'm going to do is show you here, where's the table here, air guitar players, and it's empty. Go here and have a table air guitar players, and it's empty as well. But let me show you this here. Select PG is in recovery. This is a master, so it's going to tell me false, correct. Same thing here. It's a master, well, you know. So what I'm going to do is, let me get my sheet here. I'm going to insert some data here. Some of the winners, I don't know these people, so I'm not really endorsing them, but at least they won here. What did I do here? Oh, so I made a mistake here. I missed the values here. Values here. Boom, there you go. I have put the same name, sorry, twice. That's not good. Well, anyway, so look, table here, air guitar players. I have two, the same person. She actually won twice, but not the same, not twice the same year. But I mean, you see, I have an ID here, a name and a year, and I inserted the values here. And if I look here now, table, air guitar players, let me change the display. I got the information here, and is exactly the same, yeah, which is what you expect with replication. No surprise there. But let me look at the replicas of this. Let me do the star here. Start. Boom. This is the metal node. Then let me do PSQL. Let me connect to backend. There you go. And then let me do select everything. Select everything from is exactly the same as table, and then the name of the table. And then I see I got this. I didn't even get the information. I just started and got the physical replication here. So everything that you replicate logically to a primary node or master node is going to be replicated physically to the other nodes. The things here is that I can insert other values. So these are winners in Oulu, but I also have winners that come from backend actually, also one in Oulu. So this is another female air guitar player, Aline the Devil's Knees Westfall. So if I show you here the table here, air guitar players, you get three values. Note that I use an ID here kind of to avoid conflicts with the information that comes from the other side. If I use here number 3, and then the other master also write on number 3, I'm going to get a conflict, and I don't want that. The reason I can write here is because this is multi-master. So when you do multi-master, you have to deal with conflict. It's an important thing. So if you just have standbys that follows what the master said, there is no conflict. The master says, this is the information, and the others have to accept it. If you have logical replication, both can write. So when you have two things writing, you get conflicts. And you have to deal with this. Conflict resolution is something important. So if you can see here, no, this is the metal node. This is Oulu, the green one, because of the northern lights. Yeah, this is influenced by the northern lights. You still have the first two values. Yeah, so logical replication is in only one direction, right? If I do it from the other direction, I have to be a different table. They cannot be like mixed. That's why you need bidirectional replication if you want to have that. But this value that I put here, if you look at the other one, it also got to the replica because it's a physical replica. So you can see you have kind of a sort of Postman's sharding. Some of the data is in this set of nodes, and the other data is on the other set of nodes, thanks to logical replication. So you can build actually sharding on top of logical replication. So this one is a physical replication of this one. I can write here, so I can insert values that are different than the original source, which is the publisher here. Now, something very important here, it is the air guitar players table. It has here an integer for an ID, which is the primary key. This is very important for logical replication, because if I update the name, let's say update air guitar player set name, and I think the guy who won in 2015 is was called Aristotle, because of air guitar playing. Yeah, so where ID equals 2. Good, I update one, I look at my table here, and it changed. So now I have Aristotle here. So it works, that's good. It's good that I made a mistake to put twice the same name, so I could show you the updates. Now, why this is important? Because I have another table here, which is called XY, which has 2 integers, but none of them is a primary key. So what I'm going to try to do is I'm going to try to add this to the replication set. And what I'm going to do here, so let me see here. This is coming from the PG logical stuff. So I do, sorry, the error came a little bit too soon. PG logical replication sets add table. Yeah, so I'm going to add to the default replication set the table XY, and tell me, sorry, error, it's not possible. Why is not possible? Because it doesn't have any primary key. So when you don't have a primary key, there is no way to tell whether you're updating a row, because if you don't have a unique way of identifying it, you don't know which row is. So I cannot do neither updates nor deletes. I can do only insert or truncate with this table. So what you have in PG logical, it is actually here a way of doing, this one works, insert only. So I can have a replication set that is insert only, and whoever subscribes to this is going to get only insert from my table. This is useful when you have like things like monitoring information. They have a timestamp and a temperature. It's always increasing. You're not going to say like, oh, sorry, yesterday actually it wasn't 10 Celsius degree, it was 25. Nah, man, you shouldn't have this kind of updates on the information. So that's logical replication. And we have another poll for you. And this is the last poll for you, whether you're using or not logical replication, whether you're planning to use it or not. So that will be information that you can give us. So you go and check the polls, and then you can tell us about logical replication or not. So master, you can do from major version to another major version. When you do this, it is important that all your tables has primary key if you want to send updates and deletes. So that's why I wanted to show you that error message. If you have some tables that are insert only, it's fine. You don't need the primary key. But if you want to really do an upgrade, it's better that everything has a primary key. Good. So you can also say, in a physical replication, you have to copy entirely everything. In logical replication, you can decide which things are going to be replicated. You saw in Olu, I have 2 tables, and I'm only replicating 1. You can also say like, okay, this project, which is in this instance 9.5, is going to be run in version 12 now, because all the tests have been done in version 12. But this other database is going to go to another instance running version 13, because otherwise this 9.5 was too large, and this is a chance to split them in 2. Yeah. So you can do 12.12 or 13.13. You have options now. It opens you a lot of options. You can upgrade the entire cluster. So as you saw, you can have this kind of architecture, and then do another cluster, which is a new version, with exactly the same organization. And then you do from master to master logical replication. And as you saw, whenever I send something from Olu to Vakin get replicated to Metal and all the other stuff. So this is the best way to upgrade your entire cluster. Instead of doing only the upgrade of the primary and then rebuilding as fast as possible your standby nodes and hoping that it's not going to crash until you have them all, it's better to just use logical replication and do it like this. So, and then you throw away your old cluster. Then you had the upgrade of your full cluster. Good. So last thing, progressive metal. This is when you start mixing some different kinds of style, different kind of tempo. And you can also do the same with PostgreSQL replication. So postgressive, somebody told me in a different presentation, postgressive replication. You have version which is going to be upgraded to another node. So logical replication from master to another master in a different node. This one can replicate to another master here. which is a different version, and having not a bidirectional stuff, but a different set, it can also replicate back. Yeah. This one can have cascading replication with asynchronous replication, physical stuff. And this one can have read-only scalability for certain amount of node and synchronous replication for preventing data loss, okay? One of those can be also, remember, with a delay to prevent human errors. And you can also have like a major node, large one, which is getting with logical replication and data warehousing. So it collects information from everything. And so that's the best way of doing actually data warehousing. Instead of using data wrappers, stuff like that, just use logical replication. It works. It's very efficient as well. And then also when you do backups, we started with backup recovery and we come back to backup recovery now. So it's nice to close the cycle. So we're closing the presentation now. You can also just don't take PG dump, you take a physical backup and then you stream your walls. So you're constantly sending your walls. And the walls can go either from the primaries, as in these two cases, because this one doesn't have any alternative, or from the standby nodes. That's also possible. So you stream from the standby nodes so you don't expose the primary to all the charge. And now this is the same diagram that we got in the beginning. So now it's pretty obvious to understand all the errors and things like that. So I hope that you understand this much better than in the beginning. Good. So conclusion. Instead of having a bullet points with conclusions, I want to show you the tree of physical stream replication. Remember that the roots are in backup and recovery. And then by changing a little bit things like constant recovery, you have physical replication. You add the replica from the replica, you get cascading replication. You wait until your replica gets the data before saying that you committed the value, and then you get synchronous replication. Instead of having physical replication, you want to decode the information on the wall before sending it, and then you get the downstreamer, which is going to apply it. Then you get logical replication, which opens for a lot more things. If you want to have a presentation only about possibilities with logical replication, I will be happy to contact a friend and do it. Well, I can do it as well, but let us know. Yep. So that's it. And I want to close with again with Kiko Loureiro, which has a very nice quote about open source. So this is what he got as motivation for having his album open source. And I'm going to just read it so I get it right. It says that open source community brings a higher sense, the open source, sorry, brings us a higher sense of community, yeah, and enhances our creativity and possibilities. So that's why it's good to share knowledge and share code and all this stuff. So why not take this concept of open source software to art, to our art, to our music? That's what Kiko Loureiro says as motivation for his open source album. So, and with that, I would like to finish and thank you for listening. And if you have questions, I hope that we have some time to answer them. So thank you very much.
Yes, great. Thank you so much. I just want, before we jump into questions, I just want to let everyone know that you will receive a recording of this session as long as with the copy of the slides. That will be coming to the email address that you used to register, and it will be coming later today. So have no fear, you'll be able to revisit this as well. Okay, so let's jump in. We had a lot of questions come in. We're not going to be able to answer all of them. Like I said, we'll follow up with any that we are not able to answer. But let's see. Lots of great feedback. Okay, let's see. What question do we want to start with? Are there any downsides or caveats to logical replication? Are there any situations where logical replication is clearly inferior to other types of replication?
Yeah, the caveat that is the important one, as I mentioned, is the primary key. So a lot of projects that we have seen start like planning the whole thing of logical replication, and then when they start to put it in place, they realize that many of their tables don't have a primary key. Actually, this was a good discovery for them because we say like, oh, actually, we are having some duplicates here that we shouldn't have. So we should actually first clean up the data at the primary keys and then have the replication. So this is one thing, the primary keys that you need to take care of. In terms of how much overhead you have with logical replication, is really little. If you compare with the oldest way of doing it with, with triggers, that one was really expensive. Logical replication as it is done now with logical decoding the overhead is minimal. It is adding some extra information on the wall so that it can be done with logical decoding. And in terms of performance, actually, sometimes it sends even less data than a physical replication. So that's also something that is cool. Because if yeah, all the things of vacuum, for instance, in physical replication gets sent to the physical replica. In logical replication, vacuum is not being sent to the other replica. So actually, it is more efficient if you just want to send data. You don't want to have all this auto vacuuming stuff, because the master at the other side is going to do the vacuum itself. So overhead in logical replication is kind of, in some cases, a little bit more. In some cases, it's actually more efficient. So I would say planning your logical replication with primary keys is the most important caveat for that. Yeah. Yep.
Okay, so this question came in a few times. Is there a specific version that's needed to run logical replication?
Yeah, so there is native replication provided by PostgreSQL starting from version 10. Yeah, and this one is not the one that I show. I show the extension with PG Logical because it has a little bit more features that you can use. And in general, what we advise is that native replication starting from version 10, it is good for a logical upgrade. Yeah, from one version to the other, major version to the other. But PG Logical is best when you want to have this kind of combination, like when you have your data warehouse that is collecting information from multiple sources. And PG Logical can be installed as an extension starting from version 9.4, which is already not supported. So all the supported versions of Postgres now allow to have PG Logical. Yeah. Yep.
Okay, we're getting right up on the time. There was a lot of feedback that people loved your references to metal. And so someone wants to know what your favorite band is.
Okay. Well, that's difficult to answer because it depends on the style. I have many different favorite bands. I mean, power metal, for instance, I was listening to a lot of Halloween before this presentation. That's why I don't know if you listen to Halloween, you will see that one of the texts that I use is coming from them. I also like a lot Nightwish. I think with Floor Jansen, it went really a different level. And I've been listening to them since the beginning of the century. So I also like them with Taria. But things like Enslave, for instance, I think this is started like black metal, but it's really becoming a really good progressive metal band, and I like them a lot. I also mentioned Iron Maiden, of course. So one favorite band, it's difficult. Kiko Loureiro, for instance, I love it. Is just instrumental music. So we can talk a lot about metal music. Good.
Great. So just being cognizant of time and that people might have to jump to new meetings, we'll wrap it up right here. Thank you all for all of your great questions and engagement. And like I said, we'll follow up after the session. We hope that you all have a great day. Thank you.
Bye, everyone. Cheers.